Right, advanced higher physics people. We're going to go into some new piece of work, and you'll have some problems to do at the end of this, and we'll do a little bit of advanced higher physics past paper work as well, just to kind of show where it comes in. But today we're going to look at it's called using calculus methods to solve kinematic problems. Now, it might sound fairly grand, but actually it's just applying what you've learned. If you've done the proofs, I think most of you have, or all you have, it's really reliant on the fact you know that ds by dt equals v and dv by dt equals a. Now, can I just explain something else to you? This is also can be written as d squared s by dt squared equals dv. That just means second differential. Of s. Don't worry about that too much. Just if you see this, don't panic. It just is like if you differentiate the expression for s twice, you're going to get the acceleration. Okay. Now, so let's go back to let's do just as a problem. All right. But so let's take an example. I really mean the motion. Now, I'm expecting you to take some notes here. I know you have jotters. Pull out an old physics jotter. Start taking some notes yourself. You know what's happening next year, so take some notes. This is what I would give in the start of this lesson in school. So I'd be saying, write this down. So the motion of an object can be described by an expression for its displacement with respect to, remember I said this last time, with respect to time, i.e., e.g., as for example, s equals 3.1 t squared plus 4.1 t plus 6. You recognise that as a quadratic, and that will, you can actually use quadratic formulas later on in this. So what can work out from this thing here? So what can we do with this? Right, so first of all, so from this equation, we can find an expression for v. Well, how do you do that? Easy enough. You know, ds by dt equals the top above v. So that's going to be d by dt of 3.1 t squared plus 4.1 t plus 6. If you differentiate this about, memory work for you, but if you differentiate 3.1 t, differentiate this bit here, you get 6.2 t, because remember the power comes down by 1, and they multiply what was beside the t first if you do that. Plus, if you take the power of t here, it's dropping 1, so it just drops to 0, which is 1. T to the power of 0 is 1. So it's plus 4.1, and you differentiate it accordingly enough. Okay, so the expression for v is 6.2 plus 4.1, 6.2t plus 4.1. Now, that's all very well, but they don't ever really finish there. They often get to work something else out. So what they usually get to work out is the initial velocity. So initial velocity when does that happen? When t equals 0. Initial velocity when t equals 0. So v equals 6.2 times 0 plus 4.1. So v equals u equals 4.1 meters per second. Now you have found the initial velocity. Brilliant. Okay. Now, next part. Also, since dv by dt equals a, you can say, well, if I differentiate what just worked out, found for the velocity, and get an expression for the acceleration, or find the acceleration. That's going to be d bracket 6.2t plus 4.1 by dt, and that's going to give me 6.2 meters per second per second. So that means it's a constant. It means it's a constant acceleration. So it's a constant acceleration. So the object has a constant a. All right. Now, honestly, that's so much of what you have to do. The only thing that's a bit complicated is if it's changing acceleration. If you're advanced higher, you're never going to use changing acceleration. But higher, advanced higher, you can touch and changing acceleration. So what was it changing? What do you think? Just as you're going through this, how would the expression look for S as a changing acceleration? What would be different about it compared to the one we've just done? Give it a few seconds, pause the tape, have a think, pause the tape, pause the video, have a think. So S equals, of course, you're right, it's got a cube power in it. So it's 4t3 plus 3.1t squared plus, this is just an example, of something that's got a varying acceleration plus 6. So you get v equals ds by dt equals, I'm not going to write the whole thing out as I did before, I'm not going to write this bit. So it gives you 3 times 4 gives you 12, t, take away 1 off the power, t squared plus multiply that, gives you 6.2, t, take 1 off the power, just don't put anything in there, and then that becomes, take minus 1 gives you 0, so you get plus 4.1. That's the velocity. A is going to equals, that's like a D, isn't it? Change that, make it look more presentable. A equals dv by dt equals, same thing, multiply that together, gives you, I'm not going to write this, going to be confusing actually, I think you can follow what I'm doing here, 24t plus 6.2. So what does this mean? It means that, so, this means that the object has a changing acceleration with time. Okay, right, let's look at a past paper question. Now, what I've got here is the space shuttle taken off. There's the equation of motion for it. It says find by differentiation the equation for the velocity. Oh, well, hang on, it can't be too hard. So A part, how big is the black holes, which is not quite got there yet. This is higher than ever, so it's good though, if you like it, you get there. 3.1t squared plus 4.1t. So therefore V must equal ds by dt equals 6. I promise you, this is just taken randomly by me. This seems to be the same equation. Plus 4.1, and A equals dv by dt 6.2 ms to minus 2. Okay, at what time will the vertical velocity be 72 meters per second? What do you do here? I'm sure you can figure it out. Because you've got this thing sitting here, v equals 6.2t plus 4.1 for the velocity, so you write, well, v equals 6.2t plus 4.1. And they're saying when it's 72, so you say, okay, so let's make that. So 72 equals 6.2t plus 4.1. So you would find in advance how they never let you have easy numbers, it's always odd, strange numbers. Equals 6.2t. I will know that for my calculator. going to be 67.9, 6.2t, so t is up here, t equals 67.9 divided by 6.2 equals basically 11 seconds. Fine. Now, to save myself a wee bit of space, I'm going to go up here, part 3, calculate the vertical linear acceleration during this time. Oh, wait a minute. I've already done that. I didn't mean to do it. There it is there. 6.2 per second. Okay, that would be actually probably worth more than 4 marks. This is an old advanced high paper, so that'd be more marks than that. But you get the idea. It's quite straightforward. And the homework I'm going to give you is, or the work, it's not really homework, it's the work I'm going to get you to do in your virtual classroom is here. It's page, written down somewhere, page 17 of the notes I'll attach in the team, questions 1 to 8. I want to try and do these derivations here. Try and make sure you can do these, follow them without just, it's in the first video. They're all on YouTube actually. I'm now going to link this to the YouTube physics channel. So it's just right, it's called Physics with Claire, am I right? And you'll see, I'm going to stick all the advanced high videos up there. But there you go. And I'll make that for Friday. What day is Friday? Friday must be the 29th. And because you made it this far as a bonus feature, I'm drawing you a wee duck. Hope you enjoy that and happy studying.